Okay, great. So we're on our page, rockefelleruniversity.github.io. We introduced ourselves at the beginning to the course, and we started on Intro to R. So we learned a little bit about how we can handle data in R, the different data types, vectors, matrices, factors, data frames, lists. And then we saw that we could read these data structures in from files, which is what's going to be most useful to us. And we can write the results back out to files. And we learned a little bit about how we can do loops, some programming aspects to R, so conditionals, given this, we should do this. And then Matt came and introduced us to reproducible R, and in particular, he focused on our GitHub, which is how we're hosting all these courses, how you can get help by clicking these get help things. So a lot of our courses are built on GitHub. And actually a lot of the work we do goes through GitHub. So it's a really important tool to learn. So we're going to come back to reproducible R once we learn a little bit more from this course, and this one we're going to cover today is plotting. Okay. So if we look through, we have our usual setup. We have our getting help. If you want to get help, you can click here and it will take you to hopefully the issues page. Can't be found. So there's some questions there, which I think Matt solved a lot of. System requirements, what you need to set up, what packages you're going to need to install. You're going to need to install all these packages, and you can just copy and paste that into the RStudio to get it. And then we material for today. So all the material, as ever, it can be downloaded here. You can download that. I'll download it to your computer, unzip it, and it's there that you'll find all the copies of the courses as before. So we're going to run through our first session, and it's quite a long session, but it's quite simple in this first hour. And this is going to be plotting in BASIC. So as always, we can follow the slides here. And we're good to go. So all the prerequisites you can download, I just showed you. Once you've got them downloaded, you can actually just hop into the directory. I'm going to share my whole desktop, to be fair. Once you've downloaded them, you can just unzip them in your downloads directory. And inside there, you go inside the R course. And there we have our whole course available to you, downloaded, and you can run through it there. Okay. That's not the actual course though. Great. We have to set our working directory, and we can cover this again in the exercises. We can just either set our working directory to the R course folder in our plotting in R directory we just downloaded. So this directory here is where everything of use is. And we can either do that using the command line in the R console, or we can do that in R quite simply here by session, set working directory, choose directory. I'm already in my downloads, but plotting in R course, and then okay. So then our R materials here, all the data we need for exercises is here. We can work in that. Okay, so I think one of the main reasons that we came to R, a lot of people come to R, is because it has excellent graphics and plotting capabilities right out of the box. So you don't need, and we've shown you how to install libraries, and I can tell you those are incredible. I'm going to show you some of them today. There are an incredible set of libraries for graphics in R. We're mostly going to concentrate on kind of static graphics you would put in your paper, manuscript you can print. But obviously, I mean, I think we touched on it in the second session. Lots of great web interactive graphics you can do in R as well. So you can mix a bit of JavaScript with your R and produce some really nice interactive graphics. But we're going to cover static graphics today. And as I was saying, R compared to things like Python, and Python has great graphics as well. But MATLAB, R really does, I think, win. It has the biggest variety of graphics capabilities. Most of these, which you'll come across out of the box or quickly in R, are the base graphics. So these are out of the box. You don't have to install anything. R comes with this plotting capability. You have the lattice package, which is very popular, but we're not going to teach you. And we have the ggplot package, which is what we're going to cover in our second and third session. Okay, so base graphics. This is what you don't need to install anything. You can run this without having to load any libraries. And these use what is called a pen and paper model for plotting. Okay. Lattice, ggplot, they're built on routines which come from something called grid graphics. We're going to talk a little bit more about ggplot2 later on, but effectively, based on our graphics, you can think as following the pen and paper model, Lattice and ggplot. They're really building blueprints of the plot and structure for the plot. So what is this pen and paper model? Well, very simply, it's once you've made the plot, like when you were drawing on a piece of paper with a pen, you can only add elements, right? It's a permanent mark on that piece of paper. I can't remove something once I've drawn on it. This can make it very hard to update. Once I put my axis there or I put my line, it's going to be very hard to remove that line using this pen and paper model using base graphics. But there are some serious advantages over some of these other packages, especially some of the interactive stuff. Because you are writing on your pen and paper, you're not building up a blueprint. You really have to hold less information in memory. It's a lot easier to deal with, and it's a lot faster. So some of these plots we will do in this first session, you will continue to use despite maybe knowing more advanced plotting schemes later on, because they are faster and we get the job done. Building a plot then, given that we can't take things off, becomes a bit more of a stepwise approach where we will add the features to the plot as we go along. So we might add our box, then access to our box, and then a line in our box. Okay. So the first thing we're going to get started with the most basic type of plot we can make, and this is a scatter plot. We need some data, and we're going to get some data just created ourselves. So we can use our combine function here. We'll learn about that in our first sessions. And we can give it some numbers to plot, and we give it our arguments to the combine function separated by comma. This will create a vector called treatment. I think we can just show you that quickly. I'm sure we know how to make a vector by now, but we have a treatment vector there. Okay, so a normal vector, no names, just a standard numeric vector. We can pass that to our plot function. So this is base. We don't need anything else loaded. We don't need to have any libraries like library load or anything. Just run plot on our vector. So this vector we just created, and it does a lot of the work for us. The box. We have our scatter plot. We have the values from our vector here. Sorry. So we go up to 80 and we start quite low. So we have them along this axis here. And it's actually named the axis the same as the variable we put in. So it's clever enough to know that we call the variable treatment. We might want that along this axis. And then along here now, we have what is the index. So if you remember, the index is the position within the vector. So if this was a time series or something where the index is useful, already we have kind of a useful plot, right? You can see that this is going up over the indexes. So that's the basic, right? Without having to do anything at all, we can plot our vector across its indices, really with just one line. We can do a lot of customization to this plot in base R. And one of the first things we can change is we can change the type of plot we're going to make, and we can control that by just passing one more argument to our plot function, the type argument. Okay. So here we're going to do comma type equals O, which stands for, I think, overlay. So we're going to get points, but we also get a line overlaid on top of those points. Similarly, we can do things like type L. It's going to give us a line plot. I think the basic is P, which will give us a point plot. We can come back to doing this, but like with every function, if we need to know a little bit more about how it works, we can do question mark the function. Here it's plot, and it's going to give us a great help page. So I'm going to come to the help page in a second. You can also add a title, which is obviously very useful, and a subtitle. Using this sub, or the main argument. So here we again just give it our vector treatment by its index. We go main and we just tell it it's going to be my plot. And we can do sub, and underneath it, it's going to give us a little sub kind of title, a plot. We can also customize, you want to control this. So by default, treatment, the name of the vector. Often you're not going to name your vector something particularly useful. So you might want to just control how you label your axes directly, and you can do that again in plot. We provide the xlab argument, position, ylab, we give it score. Now we have our score here, on the y, and across the x, we're going to have our position. We can also control the labels on the the orientation of the labels on the argument using this LAS argument. I think that's line axis style. Yeah, that makes sense. Line axis style argument. So here we're going to do las equals 1, and it's going to try and put everything perpendicular or in the really the correct orientation. Here we can do las equals 2. Now this is going to be in this orientation, but along the bottom, we can see we have 1 kind of rotated. Our axis labels being rotated 90 degrees. And there's a las equals 3, which will rotate these for you. Maybe a las equals 4, rotate something else. You can also control point size. So often we want to make these bigger or way smaller. We can do that using this CX character expansion parameter. So if we want to double the size of the characters, we can do 2. If we want to make them 50% of the original size, we can do 0.5. Or we can also change the type of character we're going to use for our points. So here I'm going to use PCH1. That's the default. Most of the time, or maybe it's your opinion, but I use PCH20 because it's a nice solid dot. You can just select, I think there's 1 to 24 different types of points you can have. Similarly, we can control line width with the LWD parameter, line width. Here I'm going to do type equals line, so I actually have a line to control the width on. And I can be 10 times thicker or 50% thicker. And I can also control the line type. So I can do LTY as 1, and that's the default for a standard line. And then LTY equals 2 will give me a dash line. LTY equals 3 will give me a different type of dash line, and so on and so on. An important argument we can control, it's going off the side a bit here, is color. So we have to use col, but we can do plot, give it our treatment, tell it's a line plot, and now I'm going to tell it the col is red. Okay, so just the word red. And it's going to give me a red line, and then we have a selection of colors. I'm going to show you where you can choose them from. Then we can do Dodger blue. So my old boss was the author of the diffbind package, and he loved Dodger blue. So we use that here, and you can get that blue line. So if you want to choose a set of colors which are built into R, you can come here to this R color chart. It's got like a PDF, and it tells you through all the different R colors which are built in. So burly red, burly wood. Lots of grays, lots of blues, lots of reds, lots of yellows, whatever. Lots of selections of different colors you can choose from there, straight out of the base R. I'm going to show you in a little bit later. You can actually get some really nice ranges of colors and color charts, or design your own color charts using some of the packages available to you. So just to emphasize the help for plot now, I just want to come in here and do plot. Remember, this is it's got lots of options, and we're not going to have time to go through them all. Within the base, this is the generic plot. And you can see already it's got lots of useful information for us. It tells us we can actually provide 2 things to plot. So at the moment, we're just plotting 1. We could actually plot X versus Y, so we can get our XY scatter plot. Arguments to be passed to the methods, so I'm going to see par. I want additional knowledge of some of these graphical parameters, but it's going to show me some here. Type. And I have the different types I could have plot. I could have done a stair steps. This is the overplotted. both these ones we saw just now, and then some examples. This is quite common. I think we've come across this already, but often you'll need to dig down a little bit more in the help. So if I go to par, you can start to see like lots more information, lots more of these parameters we've set. We can set. And go down here. I think it's even got things like the different line types. There we go. So this is the last thing I was talking about. So whether or not you're parallel to the axis. So 0, always parallel to the axis. 1, always horizontal. Always perpendicular, always vertical. You can see that, so yeah, PCH, so these are the different types of plot points we can have. And again, I have to go into another graphics to go and actually work out what I can choose, but here we go. So I have from 0 to 25, and that will give me different types of points which I can plot in my using my plot function. So it's extensive, the help for plot, and it is an extensive function as itself. But as we'll see, plot is a nice generic function. We can do lots with it, but there are also functions built into base R to do particular types of plots. Okay. Always, as ever, if we go a function, it's got lots of complexity behind it, question mark plot, or even question mark par here, and you can get the list of options. So like we just saw when we did our question mark plot, it showed us we could use 2 vectors to plot in here. And that makes sense with an X and a Y plot, so a scatter plot, X, Y plot. We want a value for X and we want a value for Y. So I'm just going to create another vector. I'm going to call it control. It's going to be 0, 20, 40, 60, 80, 100. Now if I pass this to the plot function, as we saw in the methods in the help, it can take an X and a Y. So the treatment now will be plotted along the X. And the control values now are plotted along the Y. So then we have our X, Y coordinates for our values. That's great. So that's how we can make our X, Y plot. But often we want to try and put 2 lines, maybe running across a time course or something side by side. Okay, so to do that in base R, we can just use this lines function. And now we're going to start talking a bit about we're going to start seeing the effects of our pen and paper model. So we can use the lines function to add to our plot. Okay, so in this case, I'm going to first plot our treatment. I'm going to make it an overplot. I'm going to set the color to be blue. And then I'm going to do a line plot. So that other vector, I'm going to use the lines function, and I can give it the same similar arguments, type. PCH here, I'm going to change to make it stick out a bit. The line type I'll change. The color I'll change. And now I have 2 lines on 1 plot. But if you look, there's already a problem. And that is that this line is going to go off the end of the plot. Okay, and this is because of our pen and paper model. This, when it made the plot, dictated the limits, the range of my box. So when I made this plot, it looked at the limits of treatment. I'm not sure how long ago we actually made treatment, but the maximum value in treatment was 80. So in order to fit, it's doing a lot of work for us. In order to fit it in, it made the maximum 80, or just above 80. But as we can see in the control, we have value of 100. So that's going to go off the edge of the plot. So we need some way of fixing that up front before we make this plot. Because once we've made this, there's no going back and changing the axis. Right? This isn't how this base graphics works. It's pen and paper model. So what we need to do is up front know about what we're going to plot in the lines. Okay, here we do. But if we're, say, reading from hundreds of files, maybe we don't. But we do need to get this information, the limits of our control, so that here we're going to manually extend our Y limit using this YLim argument to account for the larger value in our control. Okay. So I can see the largest value is 100. Sorry, there's 100. So I'm now going to use YLim. I don't need to use XLim here, but I can use YLim with my plot. And I'm going to say set the Y limits to start at 0 and end at 100. Okay, and it always gives you just a little bit more. And then when I do my lines plot, you know, I've got enough space in my original plot that the line now fits in. So, you know, we've looked at that value and then we've changed this manually. So what we really want to do is probably have a function which can take some data and return to us the limits of that data. And we have a function in this range function. Okay, so range returns a vector containing the minimum maximum of all the arguments given to it. So if I was to give it multiple vectors, it looks in all these vectors and it finds the minimum and the maximum of the range. So here I'm going to give it my treatment vector, I'll give it my control vector, and all these arguments are separated by comma. Because neither, oh, this control does actually. So I don't know why, but I think when I first ran this, I didn't think I had a 0, but I wanted to have a 0 in my range, so I put that there. I do range, and it knows now the lowest value was 0, the highest value was 100 from our control, this value here. And it returns to me this vector of length 2 with the minimum and the maximum in my range. Okay, so now I can use that for my setting my y limbs and my x limbs. So now I can do plot, and I'm going to do treatment. I'm going to do type equals O, color equals blue. I'm going to set the range. I would have got a nice neat plot with my ranges all fitting in now. In this case, I'm going to start to show you now how we can build up a plot from scratch, because we know that that pen and paper model maybe failed us a little bit by putting everything up front. So I'm going to turn off the axis here. I'm going to set that to be false. And I'm going to turn off all annotation for my plot. Right, so everything which isn't the actual data plotted, I'm going to set that to be false too. We know that this area we're going to be working in is going to fit our data because we've set the range, but I've taken out the axis and the annotation anyway, just so that we can start to do this ourselves and not worry about having to change things later. The first thing we're going to do is use this axis argument. So we don't have to do this usually. Usually our plots contain our axis for us, but we can control this ourselves by turning off the axes when we make the plot. So I've turned off the axes here, turned off all the annotation. And we can specify our own axes to the plot by using axis function. We tell it which side of the plot to be on. So I think it's 1, 2, 3, 4. So we say 1. And we tell it at what points we want it to make these ticks. Well, we know that our value in our index was running from 1, 2, 3, 4, 5, 6. I'm going to give it 1 to 6, and I'm going to tell it to put at those positions Mon, Tu, Wen, Thurs, Fri. So just the days of the week. And now I can build my own axis to go alongside this plot, just making it up specified from my at positions. Where do I put these labels? And then what labels do I want to put there? Let's check that. I'm not sure if, sorry. I'll check what the side is. So yeah, the axis is placed as 1 below, yeah, 2 left, 3 above, 4 right. So this is where you tell it which side of the plot to put that particular axis. Real struggle getting around my screen today, sorry. So then we can make our y-axis the same way, and we're going to display tick marks every 20, tick at every 20 marks. So to do this, we need to say axis. We're going to say second 2 here. So 1 was the bottom, 2 is this side, 3 is that side, 4 is that side. So we're going to go on this side now. I'm going to tell it our label axis style. So I'm going to be 1, which is going to be like this is arranged, the orientation, the angle of the labels. And then I'm telling it to work from 0 to the end of the range, so the maximum value, by steps of 20. Okay, so now it's just going to add labels to the axis, second side, this side, and it's going to do them in steps of 20, working from 0 to the total length of the axis. We can now add a box to this, right, to fill in the rest of the axis, and there's not much which we have to do. We just write box. And then it's going to put a big box around on top of our axes. Remember, everything's being plotted on top. So we're building this up as we go along. So now I can add my lines. I could have added this at the beginning. Lines, give it the plot, give it the vector, sorry, tell it the type. So an overplot, tell it the character, 22, which is obviously a square, the line type, dashed, and then the color. Final thing we're going to want to do, and it can be kind of tricky to work with legends and base plots. Legend function, I feel, makes it kind of easy. We just need to specify this legend function. We need to tell it a few arguments. We need to tell it where in the plot we want to be. So very simply, you can say top left, it's going to put it here. You can say top right, bottom left, left, top, bottom right. So you can just give it like a description. It's got a list. If you do question mark legend, it will tell you the list. You can actually, I think, I'm not sure if I say this, you can also tell it an XY position to actually put it in. So you could put it exactly over a particular position in your plot. We tell it what we actually want to put in the legend. So here we want to have a legend covering treatment and control. And then we need to tell it in the pairwise way, right? So treatment was blue, control was red, treatment had PCH1, control was PCH2, and I tell it the line styles too. Okay, so it's going to make the color blue for that one, red for the second. It's going to be the PCH will be 21 for this one, 22 for that one, 1. Okay, so we have to do a little bit of the work ourselves there when we're doing our legend, because there's really no connection to the plot, right? We have to re-specify what our lines mean, and we have to specify what the actual line was, right? The color, type, the character there. So I guess this is the last thing we're going to do is change thickness on this, and we can do that here. Where we have our full plot, which is the plot on the one before. So everything together, we've taken our treatment, which was our original vector. We made an overplot. We gave it the color blue. We made the width 1. We told it the range by calculating it from all the data put together. So we did that range function, gave it all the vector. And then we told it, don't put an axis, don't put any annotation, because we're going to provide the first axis on the bottom, the second axis on the left, and then we'll fill in the rest of the box. Finally, we added our control lines plot. So we added the additional line after we'd done everything else. And then we used our legend function to say top left, put our legend of treatment and control, color the first one blue, second one red. This is the type, this is the line. And then we made them different thickness at the very end too. Cool. Was there anything else I wanted to say on that? I don't think so. So Matt had some really good points on this, and he wanted to put in some stuff on palettes, and I think absolutely right to. 4% of people are colorblind, and actually in white males, this rises to 10%. You're going to meet someone who is colorblind at a conference. You're going to present something. You're going to have someone in your lab, really, if these stats are true, who is colorblind and won't be able to get all the information you want to convey to them in your plot. They won't be able to understand it. And I used to have a genome center manager who was red-green colorblind, which is the worst thing for a genome center manager because of the dyes we used to use. And he had to have everything changed because it was a problem, and it was just making his life impossible to work with. So be aware of this up front. And it's easy to take a lot of the defaults which aren't sensible. But there are packages which make your life a lot easier. And I think Viridis, which is I think a favorite of Matt, has lots of colorblind friendly palettes here. But if you come to this link here, which is I think Paletta, you actually find inside R you have hundreds of palettes available to us. And it's actually kind of good fun to go through and get lost in all these palettes. We're going to see more about how we can use these and integrate these ourselves, but just to show you now here, we have things like the Beyonce palette, which is incredible, really. It's based on this Beyonce palette themes on Tumblr. You can have every Beyonce palette you ever wanted. You've got things like, I like this one, Vaporware, which takes you back to the 1980s, and you can get Blade Runner fonts to go with it. And actually, people were asking me how we could give them a hot pink color scheme, and you can get that too from this beautiful 1908R with its color flipped. So there are hundreds, maybe even thousands of different color schemes you can use. So you're not stuck with just this red and blue. You can decide what is your color scheme yourself and build it up, or you can take some of these pre-built ones and these things here and apply these to your own work. We're going to cover more on color schemes in our second ggplot session as well. So there are trade-offs in creating good plots, and we don't really have time to go into what makes a great plot. And I think it will be a continual challenge for you, and it's a challenge for us as we go along, and there are fantastic books on this. So here's one Matt's made a link to. Ooh, maybe I linked the wrong thing there, sorry, my thing's on the side. Fundamentals of Data Visualization, which is a great free book for you to go and review. I think the most important thing for me is this line here. Don't make your plots superfluous. Don't make your plots superfluous. You can have lots of information around your plots, which is just useless to your main plot. So I would recommend keeping it simple and just trying to convey the message, the data you want to convey. Don't try and make it too complex. Read that book. So we've shown you the plot base function, and this will allow you to do much of the different types of plot in R. In base, you also have lots of functions which allow you to do very particular types of plots. And these include things like bar charts, box plots, which are incredibly useful, but also histograms. Probably box plots are the most useful base plotting thing we have. First one I'm going to start with is bar charts, bar plots. Very useful built-in function. You have them in base. We don't need to install anything. If we pass our vector treatment, where we had values running from 0 to 80 to this bar plot function, you can see it's just going to create a bar plot. So rather than having a point, we now have these bar charts to our values of interest. Okay, run it working along. We don't have an axis here. So we have the values, and it's in the order of our index. If we want to, and lots of these types of functions for plotting have an additional argument, which is effectively this names.arg. So you can just add names along one of these axes. So here we can do names.arg, and we can just provide the names of our axes tick marks. Okay, so Monday to Saturday. Most functions have something like that. In this case, we can also actually provide names to our vector. So at the moment our vector was unnamed. Let me copy that. I can do that. So I think at the moment our treatment just a base vector. If we add names to it though, then it's got some information tied to every numerical value, and it can actually use that in the plot. So here we can assign Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and if we do a bar plot, now these names are carried over and used as the labels. So it's pretty cool. Stacking, and I think it's something which is really useful with bar plots. It's often something we want to do. We want to stack bars on top of each other to show maybe proportions of a total. So bar plot handles this really easily. We need to get some data in first to allow us to have enough data to do this. So we have some data in our data directory. We can read things from files using our read.table function. We just need to give it the path to the file we want to read. In this case, I've probably looked at the file. I know it's comma separated, despite saying .text, it's comma separated. The row names are in the first column, and it has column names too. Actually, maybe I should just read that quickly. We can have a look at it. Place. So there we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and we have a column treatment, and we have a column control. Now, if I pass that, I have to turn it into a matrix first. Remember, matrix is all one data type which is why it's useful to read in the row names into, sorry, the first column into row names, right? Because now it is all one data type. I can turn it into a matrix. Now, when I do this plot, it stacks up all the values from the treatment on top of each other and all the values from the control. If that isn't what we wanted, though, we can change the behavior, and maybe you want to see this pattern across time. We can do that by just doing bar plot as dot matrix, and here we're going to say beside equals true. So by default, it's going to try and do a stacked bar chart, but if we say beside equals true, it's actually going to do side by side our two columns which we gave it. I'm going to put treatment here and control on the right. Sorry, give me a second. Sorry, I could hear my robot, the robot cleaner thing moving around the house towards me, so I had to stop it before we got in. So we have our bar plot here. So even though this is different to plot, it can be customized in much the same way. So we can still use the same kind of plotting parameters and pass this to bar plot. So we don't need to learn a whole new thing. So here we can do bar plot, and I'm going to give it now the main, right? So we saw we can provide a main to a normal plot. Here I can do the same argument name main. I can tell it the ylab, which I want to label. So I want to change the label here. I can tell it beside equals true, clearly. I think I have another thing here. And then I'm going to provide now color. I'm going to provide that from this Viridis palette. And I'm just going to tell Viridis I want 6 colors. So it's going to give me a color for each day of the week here. And then I can add a legend to my bar plot just the same way I did plot. Okay, it's going to go now on this top left, but really more left, right? So bar plot is the same as, it's very similar to plot, takes very similar arguments. And again, like you see here with legend, we are adding to the plot as we go along. Another really useful thing you can get straight out of the box in R is histograms. So we just need to pass our treatment vector to this hist function. And it's going to tell me the frequency of values in these particular bins. Okay, so we have 3 values apparently in this bin, none here, 1 here, 2 here. Yep. So similarly, again, like with bar chart, I can change things like color. I can do that here too. I just change color argument. I'm going to say now light blue. I can change the ylim argument. So maybe there was a little bit too much, or not enough space here. I wanted to have a bit more off the top, so I can change the ylim and go 0 to 5. And here I'm going to change character expansion, but slightly different one, cx.main. So it's just controlling this part of the character. So it's just expanding the title here. Actually, I didn't realize that. Yeah, it's also giving me a title, histogram of treatment. So it's taking that and putting histogram in that there for me. One thing we really want to control with this is the number of breaks we have. Right, so how fine coarse, how fine grained is our histogram? So we can control that really easily just by saying breaks and giving it the required number of bins we want. So by default, it gave me 4 bins. So if I want to have 2, I can just say breaks equals 2, and it's going to split it into 2 bins for me across my range of data. If I want 10, it's going to break it up sensibly into 10 for me. I think this is the last 2 types of plots, right? Okay. So another really useful function, or a really useful plot you might use from base plotting, is this dot plot. And I am sorry, they've got squeezed in a bit here. But the dot chart allows you to really compare 2 values in a more pairwise manner. And if you have things like control and treatment across a 3rd group, such as here day, this can be a really nice way of just making this visualization. Like we can see that they're very different at this time point, but they're very similar at the first day. And they kind of come together in the middle a bit and then separate a bit at the end. So we can give it again our data frame or matrix to this dot chart function, but it wants us to do it in a slightly different orientation. It wants our rows to be columns and our columns to be rows. So we can take advantage, I'm going to copy that whole thing, but I'll go into R. We can take advantage of a new function we haven't seen yet, which is T. So T is transpose, same as in Excel. And you can see it just turns our columns now into our rows, and we have our row names of treatment and control. Now our columns are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So now when I run dot chart on that, it's going to give me something a little bit more sensible. If I did it before, I think it would have given me something I didn't really want. Oh. Give me something different where it put treatment there, control there, and then the days were all stacked next to each other. Notice there I had to make sure it was a matrix, so it doesn't accept a data frame. Okay, so we can use our transpose function, transpose our matrix. I guess this ensures that it is a matrix, and then I can apply that to the dot chart. Again, I can control some of the features of this using the same arguments that we could provide to the plot function. So again, they take very, very similar arguments. We can give color here, and I'm going to give red, blue. We can see what it does is color both the labels here, but also the points, and it does it, red, blue, red, blue, red, blue. It works down in a paired way. So it's recycling the colors across these values. I'm going to tell it it's a dot chart with the main parameter again, main argument again. I'm going to shrink some of the characters down to 0.05 because we couldn't fit them in here. So if I make them 0.05, I can now get a clearer look. I'm doing a bit of work for you. It's making sure that these are colored, these are colored. It would take a bit of time to do this using plot-based function. So I would say by far the most useful plot you will generate using base R is a box plot. That's because data coming in is usually a matrix from a table, or other data from DSeq2 or RNA-seq tools will often get a matrix. Boxplot works fantastically fast on a matrix. So Boxplot really allows you to review the distribution of data, say in a column. I want to see how spread out those values are in that column. And a boxplot shows you it has these whiskers here, and it shows you the minimum and the maximum value of your data. It then shows you the quartiles, the median, quartile 1, median, and the quartile 3, and then in the middle of the box, you have your mean value. Okay, so this actually conveys a lot of information. The spread of the data, the extremes, the quartiles, and the middle of the box will be the mean. So as I said, this typically comes from things like gene expression data. I want to make sure that my data, once I've normalized, has similar distributions. It's one of our fundamental caveats of analyzing gene expression data is to have similar distributions. So we can evaluate that using a box plot. Let's just read in some data first. We'll read in gene expression data.txt. Separator is \t, so it's tab separated. Header is true. We're going to say row names equals 1, again, because we want this to be a matrix. Right? Remember, if we read in something which has characters within it, so if there was a column of characters here, gene names, the whole matrix would be a character matrix, and I can't do numerical operations. So in this case, I can save the effort of having to remove the first column and reattach it to the matrix just by saying row names equals 1. And it puts this straight into my row names, this first column, and the rest of the matrix is all numeric values, so I can work on it with functions built for numeric values. Okay, so we're just looking at the first 6 values here, first 6 column rows. Now, if I apply the boxplot function to that, straight to our matrix, we'll get this. Okay, so we get our distributions of our data, and you can see these little points here. This is what we call outliers. So these are things over a certain distance away from your median, I think here. So they're just labeled as dots, and they actually look like most of the data. This is because all your data is squished right down here. And if we do a log2 transformation, which is very standard, we can apply a log2 transformation to our matrix. Now, if we do a box plot, we can start to see that they are more equally distributed. They have more equal distributions. And we can give it a Y lab again, so we can give it the same argument. We can give it a Y label. We can say log2 expression, that goes there. Again, I can specify my colors to be red, red, blue, blue, and it just cycles along. Should be reasonably easy to combine multiple plots into one overall graph using either par or the layout function. I often use par, but I'm sure that we've got an example of them both probably here somewhere. So par, as we saw earlier on, is a way of controlling the parameters for your plots which you're producing in R. So we can use par in combination with other arguments to set particular parameters for our plotting. So here I'm going to say par, and I'm going to set the parameter for mf row. So this is the number of rows in my plots. And I'm going to say mf row, and I'm going to tell it the number of rows and number of columns, how to lay out a matrix of my plots. Okay, so this is going to create a matrix, n rows by n columns, and it's going to fill it by row. If I'd done mf col, it would have filled it by col. Oh, there you go. I say that in the next line. So here I'm going to say mf row, and I'm going to say give me 2 rows and 2 columns worth of plots. And now if I set this here and I start to, for instance, here make a histogram of my expression matrix. So what we were just looking at here, I'm going to take a histogram of that. If I set this up front, it's going to put my plot there, then my second plot there, then my third plot there, and my fourth plot there. And then when I make another plot, it's going to wipe that out, and it's going to put another plot there. So it's going to allow me to do 4 plots all in one big kind of mega plot. Okay. Also, obviously, now we know a little bit about loops. Once we've set this up, we can just loop through our plots. And here we're going to loop through every column and do a little histogram as we go through. One problem with that, we've lost the title. Right? It's not clever enough to be able to evaluate what that column is. So we'd have to add, we could think about how we could add columns here. We could have col names and use I to kind of give us the index, and then use that to extract the name of the column. Maybe use that as our header here. But we've got them all in one plot, which is what we want. We can also use par to control some other features. And if you remember when we did par, question mark par, it was one of the longest helps we'll see. And these include things like mar. You might want to change the size of your plot margins. Often people, I'm not sure if we're going to cover that, I guess not. Often people want to put other stuff in their margins. Sometimes you might want to put a legend in there. We can use MGP, which is the spacing between margin elements, things like access labels and titles. Big, which contains the whole, can change the dimensions of the whole. Okay. But again, question mark par. Let's do it together. Let's see. We have tons of advice about what all these different parameters mean. I think we just mentioned mar. Yes. You know, tells you, it's even got little pictures to tell you what's going on with these plots. So PAR, if you really want to get into the forest, into the woods on this, I recommend looking into par. So we can also add custom text to our plots using this text function. This is often nice when we just want to add above a particular point something to get someone's interest. So we can use this. We can do this by first creating our plot here, and we can here we're going to do text. We're going to tell it the X and the Y position of our plot. And then I'm going to say, this is the text I want to put in that position. And I can set, again, like other functions for plotting, I can set things like col, other parameters, color, character expansion, etc. here. Okay. This is at 20 and then 60. Oh, sorry. Sorry. 20 and then 60. Let's put this position. We can also use text to actually label points as we go along here. So here I'm going to use text, and I'm going to say along the positions in control and treatment, because it's our X, Y, put the letters, the first 6 letters in the alphabet, 1 to 6. I think this is just an adjustment value to make sure that they are -1, just a little bit away from the actual point itself. Okay, so you can add texts at predetermined positions. So 20 at 60, I could add this little bit of text, and I can control the color, the character expansion. And I can use it also just to, in place of points here, I could actually put letters or words. Abline is a really useful function in R, because it allows you just to put a line across your plots, and this is often your significance cutoff, your limit of what expression you believe to be true. You might want to put that line across your bar plot. So we can use abline to set horizontal lines here with 10, vertical lines, so you can do with V, horizontal H, V for vertical, line width, color, all accepted. And then if we want to do things like intercepts, we can do our intercept and our slope, and we can control the line width there as well. So we can make all different combinations of plots, straight lines, using this abline. And this is often to define your cutoffs in your plots. So in your gene expression changes, this is the fold change I believe, or I'm willing to accept. Final useful little function we're going to talk about is polygon. So a polygon allows you to draw specific polygons. You just need to give the coordinates of each vertex. And again, you can use this to highlight a particular part of your plot. So when we're going to start to do some stuff in genomics later on, you have a long track. You just want to highlight this particular gene. You can put these little shaded boxes over it. It just draws attention to that particular part. So we're just going to give it the positions of the vertexes here. And then we can just tell it the color. Importantly, we can tell it the density, which controls the thickness of this fill by the hash here. We don't want it to be obscured. We want it to have enough that it draws attention without hiding the data underneath it. I think the final things we're going to cover is just saving your plots. So before we go anywhere, I think I'll show you how to do this in RStudio before we go through these ones. So every time we make a plot, as you saw, there are probably ways to control this. Studio. But when I was making plots, they were popping up in this plotting window here. Okay, so the easiest way to get this plot out of your session and into a file or a folder, to go save image or save as PDF. You can even copy it to the clipboard. But if I go save as image, I can choose my directory I want to save to. I can change the type I want to save to, and often, SVG and I think EPS allow you to use it in Photoshop or Illustrator. I think that's the one, SVG and EPS, particularly good for that. You can control your width, your height. If you don't want to change one independent of the other, I think you can change those there, and it's going to make sure to maintain your aspect ratio. And then finally, you can do your file name, and then you can save that somewhere. Yeah, that's a really easy way of just saving your plot. You can save a PDF too. If you're writing scripts, though, which are generating plots on their own, it's not quite going to be mustard, right? You don't want to save every single plot manually. There are ways that you can do this straight from the RStudio. So one is to, before we generate any plots, we set up what is called a device where we're going to send that plot to. So we have a device for all different types of plotting formats. So we have BMPs, we have JPEGs, we have PDF, PNG. And really, we just give these a very simple set of commands. We give it the file name that we want our plot to be pushed to, saved to. We can tell it the width, the height, The units, okay, so that's often important. We're working in inches and we're giving it units which are in pixels, can be a problem. And then things like point size. For some of these, like JPEG, question mark again, JPEG itself, you can see that it has additional features such as quality for JPEG and probably different things for all these different types. TIFF probably has a compression thing. So you can question mark, if you want to go work on a particular graphics type, you can do question mark JPEG to get all the information on it, or question mark PNG. But usually we just need to give it a file name, minimum of a file name, but we can provide information on things like the width, the height of our plot, what units we want it to be, what point size we want to be. Okay. The most basics, we just need to give it the file name. So here we can give it file, control BMP. We do our plot, right? So then rather than that going to our graphics window in our studio, it goes to that file, and then we tell it to close that file off by doing dev.off. So this is device.off, and then that plot's written to file. We'll see that in action. Do everything apart from dev.off. No, I don't have control. Let's do treatment. Okay. So I don't have anything here called control.bmp yet. But if I do dev.off, it should pop up. There it is. So now I have it. So again, I can change this now to, I don't know, JPEG. JPEG. I'm going to change that extension to JPEG. It's not going to do it for me. But nothing appears. It's prepared the device. It's got a JPEG internally, but it's not going to write it to file until I say device.off. Now I've got my JPEG. Okay, so always dev.off. Okay, so JPEG, PostScript. PostScript's really useful, again, for Illustrator. PDFs, people like a lot. Again, Inkscape Illustrator, and we can do that just as easily. PDF, we give it the file. Here I'm saying the type of size I want to save it to, A4, and then plot, and as always, dev.off. It's all written to file. Okay, so that's it for plotting, the base plotting. But we have some exercises. It'd be great if you can run through. So if we look here, I think we got some exercises just to make some of these plots. Now I've got some solutions as well here, if you wanted to run through the solutions before we run through them ourselves, just around 3 o'clock. So if you want to run through those exercises, I come back at 3. I will run through them with you then, and then we're going to move on to one of my favorite bits in our course, which is how to make plots using ggplot. So all this space is great, and we need to learn it. But much of your plotting, as I hopefully will be able to convince you in our next session, we'll be doing with a library called ggplot. Great. So I'll leave you to that, and I'll see you at 3 o'clock. The end of our last session, I think we were just going through the exercises, so I'm just going to run through them quickly now, and then we can hop into our ggplot session for this afternoon. And where do I go? Desktop. Okay. So we're doing plotting exercises. Does that link work? Oh, no. Let's get the solution. Then I should have my R. I've already run through it on the side here. I need a bit of both because I'm going to need to see the plots, but we'll manage to fit this in. Okay. So those are later exercises. Let's just hop to the exercises straight this way. Sorry. Give me a second. Okay, so we have some data. Read in the time course CSV as a data frame. It's always going to be a data frame. And get a summary of the column values. So we can use the summary function to do that. We can just see this here. So read delim, telling it to go into our data directory, read the time course. I'm going to open up the chat in case anyone had any issues. Look in the time, get the time course CSV. It's a CSV, so it's going to be comma separated. And then header equals true. So we're going to have the column names read in for us or with us. So I can run that here just so we can have a look at what time course looks like. And it's a very simple bit of data. We have one column, which is actually our time. We have one, which is our control 2. These are the values we want to plot and treatment. So then to get a summary of this, we can just do summary, I guess, time course. And give us some type of summary of the ranges within our data. Okay, plot produce a histogram of the values for control and treatment samples. Okay, so we can do a histogram from any type of vector or matrix. I think actually if you question mark histogram, it shows you doing it from a matrix. So the first question was for the control and treatment samples. So we need to do them, didn't say do them separately, so you could have done them all together. But as we have, I'm going to turn it into a matrix in this line here, and then I want to get the second and third column because they are my control columns, so I can select them using this indexing comma 2, 3. And then I can just pass that to the histogram function. And I would have got my histogram, but then, the label at the top sucked. It just gave me whatever I put in here. It gave me in my title. So I wanted to change that. And I can change that to be control. And then the xlab to be control 2. And I did the same for the treatment. So then I think the next question got a little bit more complex. You need to alter it to be on the same x limits. And I want them on the same plot. Okay, so the first thing we needed to do was set up our par parameters and then set the row. Didn't really matter here because we're going to go down. So we could have set 2 rows, 1 column. I could have done mf col. It would have given me the same result because there's only 1 column. So it doesn't matter if we work by rows or columns. So once I've set that up, let's do this now. So once I've set that up, when I do my first plot now, which is very similar to my one above, you can see it's fitting it in to only half the screen. Okay, and that's because I told it there's going to be 2 plots, and they're going to be 2 rows of plots and 1 column of plot. So I run the next line where the only thing I'm changing is the xlim. I just made them both the same. Now that puts it on the bottom. And what the problem is, and the pain you're going to experience, I'm sure, is, the next plot, you don't want it to be set up like that. So you run it and it still puts it up at the top. And then it's always going to maintain this. So to unset this, the way I do it here is we just go back and we set our MF row to be 1, 1. Okay, so now when I make a plot, it's going to fill up the whole screen. I think it's quite frustrating to people is that, once you've created this structure, how you want your plots to be in there, you need to deset it. So first thing we do in the next line, make a bar plot. So time course of control sample 1. So that was the second column here. So then I was just going to do bar plot. I gave it the second column. I actually extracted that to another vector. And then for the names argument, because actually our time started at 0, so it wasn't the same as our index. So we needed to provide the times argument, the names.args arguments. And we just give it the first column. So I think the next ones were really just to get you a bit of R mixed in. So we needed to get a bar plot of mean values in control and treatment side by side for every time point. So really we need the mean of our 2 samples for control and our 2 samples for treatment. We need the mean for each group by here rows, because the rows are the time. So if we look at this again, we have our time here, we have our control value. So the mean of this the mean of this, the mean of this. These are going to give us the values per time we need. So we can do row means. We could have done apply mean. Maybe I'll show you that now. But here I'm going to do row means of just those 2 columns, and then I'll do row means of those columns. So that will give me the treatment and the, control and treatment means. And then I can R bind them. So we saw this before. Let's actually run pieces here. So we get our control means as a vector, we get our treatment means, and then I can R bind them, row bind them into a matrix here. And then we have automatically control means and row means becoming my names. And I can just pass that to my bar plot function. Bar plot, give it that new matrix I created, give it the time course, the original matrix's times. Lab, set the column, the colors, it's going to be blue, red, alternating. And then beside equals true. That's important, I think. If we did beside equals false, we're going to stack the times on top of each other. Finally, we add a legend. And we just need to say top left. I'm going to say what I want the legend to be, control and treatment. I don't think I'd shown you this, so you would have needed to Google or look in the help. I just want color here, right? So I can't just put cull. I need to put fill, and I tell it blue and red, and it's going to give me a box of blue.
Hi, sorry, I have a question.
Hi, sorry.
It's about exercise 5. So when you put the besides true, why is it adding the bars next to one another? Because during the lecture it appeared like 2 graphs next to one another. So
just the way. So if I can demonstrate this actually. I got that. So if I do T on this maybe, and I put it the other way around, it will split it. I haven't got names. Maybe I need to give it names, but see what I mean? So that's kind of closer to what we saw in the lecture, right?
Okay. Yeah.
Still side by side. It's just that we have so many more points here that it makes it a bit clearer. It's one kind of graph. So this is like 10 side by side. I think in the lecture we showed 2 side by side, right? But it was actually the same way of generating it. It's the same bar plot.
Perfect. Thank you so much.
No problem. Thank you for asking, just reaching out. So the last thing we needed to do was our time course. And we wanted to get the line graph. So what we were going to do, and this is the thing we showed about this pen and paper, we need some way of knowing the limits in our data. And actually the limit I really care about is the maximum. So I want the max score in my data. I'm going to ignore the first column. So I'm going to do -1, because in our time course, the first column was the actual time, and that's not relevant to max score. So I'm going to remove that. I'm going to get the max, and then I'm just going to add 3 just to give me a bit of space. Okay, and that's actually going to give me enough space to then put the legend. So then I can do the plot, and I'll plot the second one, and I do the usual setup. And I'm going to set the y-lim to be from 0 until the max of all the data apart from the time column. Right? Then I get that plot, and I just add on the other lines for my other columns of interest. So I started with the plot. I started with this one, and then second, third, fourth. And then I've got all my lines there. I've given them the right colors, and then I can just do my legend at the end, top left. I tell it control treatment. Here I'm going to say color equals blue, red, and I give it LWD. It's going to give me a line, whereas earlier on when I did fill, it just gave me this block. Okay, but hopefully you can see, this is great and easy to run line plots and to add things together. A lot of base R is really fantastic. But things like this, right, having to set my limits when I want to add time additional data to my plot, that's a pain. And often I know what I want to put in my plot. And I want the plotting function to go find the limits for me. So that's what we're going to move on to now. We're going to come out of this, and we'll move to our next session, which is the ggplot, start to introduce this grammar of graphics. Am I still sharing my screen? Yep. Okay, so, like I said, this is one of my favorite lectures. This and maybe the genomic ranges lectures later on. just because it's such a fantastic subject to teach, and it's such a fantastic subject to learn, I think. Like we said earlier on, R has really extensive graphics capabilities, and we can't knock, we've just seen them, all the base graphics you can do. Makes it very easy for you, and it does some wonderful defaults. And you can make your XY plot from your matrix and your table one line. You can make your bar plots of your, box plots of all your your expression data, and it comes in as a matrix. These are really incredible, very useful plots, and you get them for free here. If you ever tried to learn how to do this in Java or something else, it's a little bit trickier. There are many different options available to you in R, and perhaps because it's so good at it, lots of people have joined in and extended it. And lots of advanced plotting packages, which you don't get from the base install of R. You need to go and install them yourself. It's install.packages or use the R Studio. Lattice is one we're not going to talk about, and Lattice has its own revivals and people who really like that package, but we're just not using that much ourselves. Myself, I can't talk for the rest of the team, but generally we don't use Lattice so much, I believe. We actually use this package called ggplot2. I think it's this package which is one of the most famous packages in R. It's hard to know if it was the most downloaded, but it might be. It might be right at the top. So this was created by Hadley Wickham, I believe in around 2009. It started development. And the aim was to produce an intuitive plotting system. An intuitive plotting system for publication quality graphics. So really high quality graphics. So this ggplot builds on the concept of the grammar of graphics, which is originally described in 2 books I've never read, but worth going and looking, I'm sure. What they describe as consistent syntax for the construction of a wide range of complex graphics by a concise description of their components. So a consistent syntax. So all these different functions we've been trying, bar plot, box plot, they had similar arguments, but they weren't the same. Right? We need something more consistent in order to create a wide range of complex graphics like box plots, like bar plots, using a concise description of their components. Okay, so that's what we're going to hopefully get from ggplot, something more uniform so that we can produce all these different plots from a very simple, short description of what we want. So ggplot, and we don't cover this, so it's part of a core, it's part of a set of libraries called the tidyverse. And they're a group of packages to make data science easy and functional. And they really are a very popular set of libraries themselves. If you want to go and check out the tidyverse material we have, you can go here, and I think this will take you to our tidyverse abridged, which is a great course Matt's put together. Just a one session there. We're not going to use tidyverse packages apart from ggplot anywhere in this course. And this isn't because we don't use them ourselves. It's because they are not the standard. So that when you come and review and you try and learn from manuals, you won't necessarily be reading tidyverse code there. You're going to be reading base. So we don't necessarily need to introduce this for our course, but it's worth checking out for your own education, and it really is a cool set of packages. We have material here, and if we have material here, we probably have a video of Matt also giving the material. So this structured syntax, this high level of abstraction used by ggplot should, remember there are negatives to this though, but it will allow users to concentrate on the visualization rather than building very complex bits of code. So we already saw, just to make that line plot, we needed 5-6 lines of code, right? That's not great for what was quite a simple concept. We want to plot these values over time. Okay, so ggplot should allow us to avoid this complex bits of code, having to write functions to plot things. It should really take care of this. On top of this central philosophy, concentrate on the visualization you need, not coding. ggplot has an incredibly increased flexibility over many plotting systems. Yeah, I think that's, of all the plotting systems, I think this is the most flexible, certainly in R. An advanced theme system for professional and publication level graphics. So now I've taught this course before Rockefeller, and many people who come to this course come back to me later on with some really beautiful plots, and they've learned how to do very customized versions of the plots we teach here for their particular paper. And they have their color schemes they like, they have the way they want to lay it out, they have the way their margins look. You really can get very, very good looking plots from ggplot. It has an incredibly large developer base. So that means there are other libraries which build on top of ggplot too. And that includes our library. So we write some packages for Bioconductor, very tailored to particular analysis types. We make sure we use ggplot in them because it allows the user to pick up our graphics and apply more modifications and changes to them. To really give you an example of this, picked up the ggplot CRAN page. So this is where you can go install it. These are all the packages which depend. So these are very integrated with ggplot, but these are all the packages which you need to install ggplot in order to work. And it is a ton. Okay, so all these packages require ggplot. And to give you an idea, let's take this one. No packages depend on this. Right? So it's very unusual. This is central to graphics, and just so many other packages have started using it. By you learning how to do ggplot, you then really learn how to pick up and understand the graphics and modify the graphics from all these other packages. And you can already see just by scanning this, there's a lot of RNA, high throughput sequencing related packages in here. Okay. Where was I? Okay, and the other thing is this large user base. So there is an incredible community behind ggplot. So you will find great documentation, and we're going to come across that later on. I don't know if I've got it open. We're going to come across that later on. Really great documentation beyond what you would get with a normal R package. Because he has his own tidyverse, his own collection of packages, he has websites describing how you use ggplot in real detail. The other thing is there's an incredibly active mailing list. Actually, I just went and had a look. So this is where we ask questions, or where we get you to ask questions. There's issues. This is the one for ggplot. They have 230 they're still addressing now, but they have 2,850 which they dealt with and closed. And these are being closed up till 4 days ago, all the way up, back came all the way until 2009. So they've been supporting this for a long time, so we can be confident if we buy into ggplot, someone's going to answer our questions, and we're not going to be stuck with a set of libraries, a set of tools which aren't being supported. Okay, so that's why we're going to use ggplot, why it's so good. But really, it's going to sell itself. So how does ggplot work in contrast to this pen and paper model? Well, like I was saying earlier on, ggplot holds almost like a blueprint, the instructions on how to make your plot. It holds all this together, and then it will cast your plot when you ask it to at the end. Okay, so by holding all this information together, it's adopting a slightly different model to pen and paper. What we need for ggplot, how it actually builds a plot, is we have data. So this will be your data frame, your information on height, weight, BMI, sex, or the pet of the patient. And then we have this really important step, which is aesthetic mapping. So this is part of the concept of the grammar of graphics, is that we can map height to the y-axis, or we can map weight to the x-axis. Got that exactly wrong according to this, but we can map these things to other parts or features of the plot. Perhaps pet, we could do size of the point. BMI, we could have color. Your gender could affect your shape. We can map the data to aesthetic parts of the plot, and then apply scales, statistics to that data, to that information we're bringing in, and then a geometry, which is our type of plot, alongside a theme, so the style of the plot, the background, coloring, the font we use, all that taken together become this graphic here. And now we have this really complex graphic where we have an X, Y plot, but we have BMI, different sizes, points. The sex gives you different colors. If you're female, you're there. If you're male, you're there. And the pet done by different shapes. So to make that plot. This is all the information which ggplot could take together and actually use. It needs information on the data, the mappings, this aesthetic mapping, information on on what type of plot to do, any scaling we want to do, any titles, any xlab, any ylab. So there's a lot of information we can specify in ggplot. But it doesn't need all this information just to make our plot. So by default, what we actually need to require, or what's requiring us to provide, is really just the aesthetic mapping. So what we want to map to our plot, the type of plot we want. So here a scatter plot, point plot. And that's all we need to actually make this plot. If we look at the code to do that, it's actually very simple. We have a data frame here, and we tell it the data. So this is like a normal function, ggplot. We give it the data. We give it as its second argument the special, another function here, this AES, and it's inside here that we have our mapping. So Y is going to map to weight, X is going to map to height, color is going to map to the sex, size is going to map to the BMI, shape will map to the pet. So that's our data and our mapping, and then we have our type of geometry there. That generates it. So that is actually one line that could be on. That would take us 30, 40 lines in base R. So let's get started with ggplot. So I've got some slides now which are going to introduce us a little bit to what's happening under the hood of ggplot. You don't really need to know this, but I like to show it this way just to show you kind of how we build up these three core components, this data, aesthetic mappings, and then this geometric. So the first thing we need to do is obviously get some data in. So we're going to load the library. Remember, this isn't base. We need a library in order to run these functions. So anytime we want to use any functions from ggplot2, we have to do library ggplot2, and it will load all the functions and make them available to us. Get our data, we can do read delim. It's in our data directory. It's tab separated. I don't give it any more. The data frame, and it has 100 rows, 17 patient rows, columns. Okay. And if we look at just the first two, could have done head here. We can see we have ID, name, and then lots of information, generic information. The person. So by default, we've covered this a little bit earlier on. R's read delim function reads in data as a data frame. Data frames are essential in ggplot2. So all this stuff we're talking about with factors and categorical information, ggplot's going to take real advantage of this. So I talked about factors being used to order your plots. It's in ggplot we're going to start to see this take effect. But as we saw in our earlier lectures, by default, when we do read delim now, I'll show you this. Am I sharing my screen or my whole session? We do read delim now, we can see actually something changed. Strings as factors, this default strings as factors. I think this is by default false now. This used to be true. So by default now, when we read in a data frame or a file, it's not necessarily going to turn all our character columns into factors. And here we can see we got our smokes. We got what looks like categorical data. It's still a character here, but it should be categorical. We got smokers, or we got height, which is more of a numeric continuous value. We can do our summary. We saw this in our last session, but anytime we have a data frame, we can just do summary, and it will tell us the type of data we have across our columns. Now we can start to get started with our. So we saw at the very beginning in these slides here, all I need is data, aesthetics, and a geom to make a ggplot. So I should be able to get this data we're going to use in the graph. That's going to be our patient information. The mappings, as we can see, we can change and select what mappings we need for our particular plot. I'm going to show how to do that. And then what type of graph we're going to use. And these are called geometries, geoms here. And they're going to have lots of functions which start with this geom. So the first thing we're going to do is define our data in our ggplot object. So we use our function ggplot, and I'm just going to supply one argument, and that's data equals, and I'm going to give it our data frame. If I run this, we're going to get this class for our newly created object. It's going to be a new type of object. It's going to be a GG or a ggplot object. Got two values for this. access both of these things. Inside our object, we can access the data by doing $ and then data, and then we can just look at the first first four rows here. We can see it's just taken a copy of whatever we put here, got put inside the object under this slot. Under the slot, it's not quite right, but and under here is 1 to 4. It's just made a copy in our ggplot. We've got that. That's important to our data, to our eventual plot, to have the data inside it. But now we need to be able to map that data to the features of the plot, these aesthetics. If we look inside our ggplot object here, so we've got our ggplot object. If we look inside the mapping slot, we have this empty, aesthetic mappings are empty. We look at another element within there, theme, we can see that that's empty. And if we look in the layers, this is where our geoms go. We can see that. So all we've got here now at the moment is data. So we can add to our ggplot, and this is a really nice feature of ggplots, is this kind of way that you can add additional elements to your ggplot. You know, it's not like pen and paper you're adding to the plot, you're adding to your blueprints here. So here I'm going to tell it the aesthetics using this AES function, map X to the height, Y to the weight. Now, if I look at that mapping element inside my object, we can see X is mapped to height, Y is mapped to weight. I still don't have a theme. I still don't have any layers. This is my geom. So in order to complete my ggplot, I just need to add this final thing. So I have my ggplot, I give it the data. Once I've got that, I can add to it the AES, the aesthetics of X mapping to height, Y mapping to weight. And finally, I'm going to assign it there. And finally, I'm going to add to it my geom I want to use. It's going to be the layer. And I'm going to do geom underscore point. It's going to give me a point. Okay, so I can now look at this, and I've got mapping. I would have data. I don't think I'm going to show it. But if I look in the layers now it's telling me I have a geom point. I'm ready for a plot. And if I just type in PC plot to my console, it's now going to just produce that plot on the left. Okay. I just want to try that out quickly. And then, right, remap. Got patience clean, and then I can do ggplot, ggplot, patience clean, that's data, and then plus AES, X equals weight, weight. So I'm not quite sure what they're called. Is it weight, height? Weight, Y equals weight. Still empty. I need to add this geom point. And finally, I'll get my. Okay, so one line, I can make a nice simple plot with our ggplot. So we know that then our plots are made out of data, aesthetics, and a type of plot, a geom. Okay. Typically, this is how you're going to create your actual ggplot object. You're going to list your data frame you want to work on here, and then you're going to provide a second argument, which is mapping, and you're going to provide there the function AES and whatever mappings you want to perform inside this bracket here. Okay, so this is a function within this main ggplot function. So once you provided that, you then add plus whatever geom you wanted to plot it as. And here now we're going to have our same plot we had in the previous slides, but now just done in a slightly different way. And I think this is the more conventional way to supply the mapping as part of this ggplot function call. So once you have this, and I think this can start to show the advantage of being able to do this plus thing, we can start to move through our different geoms really quickly. So if we want to do line plots, we have geom line, geom underscore line. Okay. Same setup data. I'm going to map X and Y. Nothing here changes. The only thing which changes is plus geom line. If I want to do a smooth line plot, we're going to come back to this in the statistics in our second section, because you can control how you smooth the line. But again, exactly the same setup. This object remains the same. I can just do plus geom smooth rather than plus geom line or plus geom point, and I will get a smooth plot. I can also do this bar plot we saw previously. I can do that using very similar, or if not the same syntax, I guess, right, as I did previously. I just need to change my mapping because now the y-axis is no longer useful, right? Y is going to be frequency in this case when I do a bar plot. So I tell it to do work over X will be now my sec. So it's going to find all the males, all the females. And it's going to make a frequency plot from that by just me pressing plus geom bar. Okay. So underneath the hood, it's going to do the statistics, calculate frequency for me. And then I do that and I will get this plot. We can do the histogram we did earlier on. Again, I don't need a Y value, right? So I can do here X, I'm going to put height now. And it's the same syntax, same setup. I just do plus geom histogram rather than plus geom bar, and I'll get my histogram plot. Okay, again, it says we can choose options here. We're going to come to that in the statistics section on this particular thing. But the syntax of this is very similar. We're just changing this last part. Occasionally, we need to change what we map to, like what aesthetics can be used. You can do a density plot, so I didn't have to change anything in the setup. Geom histogram, just change that to geom density. Do me a density plot. And usefully, I can also do a box plot. Similar to what we did earlier on, I can just do geom box plot, and I have to give it the X is going to be here, the sex, it's going to males and females, and it's going to summarize for the Y, the height values. You can also do a violin plot. So in base R, you can do box plots very easily. For doing a violin plot, you have to install a different library. Here, we don't have to change anything. All we have to do is plus geom violin. I just need to change the things underneath after the underscore, and I get a new style of plot. Okay. In case we haven't seen violin plots before, they kind of show you the density along here. So we know that a lot of our values are in this part here, whereas it's kind of hard to tell from the box plot. I like. So there are a whole world of geoms you can go look. If you go into here, I'm not sure if this is the one. Yeah, you can go through. This is ggplot, as it says, as part of the tidyverse set of libraries. Please go see Matt's course if you want to work through that as well. But they got great references, and you can get a reference for every different plot type you will find in here. Is it here? Oh, here we go, sorry. So geom bar, if you want to learn a bit more about how to specify features for geom bar, you can come in here and look at the description. Okay, so it is the R help page, but what's nice is that the R help page, it's the same setup. You don't get pictures in the examples, right? But here you do. So you can actually, I find it much easier to look at the picture and work out, okay, that's kind of what I want to make. And then I will work backwards from the example. Build up my plot that way. So I think this is a really nice feature of ggplot, is that they've got all this help you'll find in the question mark help, but you won't find the images. The images will be on there. Okay. Okay, so then we'll just talk about what I think is one of the nicest features of ggplot is this mapping of things to aesthetics. Taking your data, mapping, we just saw X and Y, but obviously we can do lots of other things. We can map shape, the color, the opacity of points. We can do all this, and we can control this very easily using this AES function in ggplot. So here we're going to set, first off, just a constant value. So we're going to make all our points red. To do that, we can just do geom point, and we don't have to specify any mapping. We just specify color, and we can say red. I'm sure I point this out in a later slide. A nice thing about ggplot, I think the guy's Australian. or maybe New Zealand. So you can do both American or US spelling of color. But all his plots, all his functionalities allow you to do that. Here we're just setting it to be red, so everything's red. Really what we want to do in ggplot2 is take advantage of the static mapping to start to update our colors, our shapes, whatever, based on properties of the actual data. So we can use the AES function, as we've seen, to do this mapping for us. So in the most basic case, we have our patient's data frame. We want to map the x-axis to height, the y-axis to weight. And then when I do my geom point, it knows to place the weight there and the height there. We do that through this mapping here equals AES. It's this aesthetic mapping functionality here. Oh, I do make a point of it later on. Okay. So rather than set colors to one specific value, we can actually use this dynamic mapping. And here I'm going to include color not in the geom point call, but inside my AES call, and I'm going to say map color to the sex column. And now when I do my geom point, it's going to color them automatically, female first as red, and then male as blue here. Do the same thing with shape. By default, it's got lots of shapes available for us. So if you put shape, again, we put the sex column. Again, I put geom point. We now have, I can't even make out what, I think it's a square or some weird shape there. And then triangles here. Maybe it's meant to be a circle. Yeah. The aesthetic mappings can be set directly in the geom points function as previously we specified. So if you wanted to, just as we've done here, where I specified color equals red, I can actually put the aesthetic mappings into here. And that just allows you to basically change your code less. I can set up my ggplot here. I have no aesthetic mappings. I just place that here. And then when I want to start to do my point plot, I just specify the aesthetic mappings required for that particular point plot. As I showed you earlier on, when you do a bar plot, you don't need all the aesthetic mappings, right? So I could still have the same ggplot and use now different aesthetic mappings for different plots. Okay. I changed O to OUI. Okay, so then actually just to show you, I guess, the ease of this, then if I wanted to make a new plot colored by something differently, the only thing I need to change is this thing. I'm just changing colors now to be smoked. There's very little correlation with smoking and height and weight. Oh, and then you can get even more complex by adding color here and then a shape on top. Okay, so now we're starting to build up our more complex ggplot plots we saw at the beginning. Males are, I think, triangles. Females, I think, we're meant to be circles here. Non-smokers, red. Blue for smokers. Okay, we haven't specified any colors, any shapes. We're actually upfront what to use. It's just filled this in from its defaults. Nicely, as though we can really now start to change style. Okay, so I don't need some of these things. If I want to now do a geom violin plot of this data, I can just use the same ggplot, use the geom violin. Now I'm going to specify x is x, y is height. I'm going to say fill equals smokes. We came across fill earlier on, and I just want to make a point of it here. So when I do color, and I do fill in this one, you wouldn't be able to really tell the difference between color and fill on this graph. But what color does is actually fills the outside of the plot. And then fill does the middle. So if I'd done color equals smokes, you would have had red on the outside, blue on the outside, but still empty on the middle. So again, if you want to get a complex, comprehensive list of parameters you can use with these different geoms and the aesthetics they accept, you can do your question mark geom point, question mark geom line, and we'll bring up the help. And we saw that that's good. Let me show this again. Geom point. Yeah, that's good, but we don't get any of the graphics here. And what was really nice about the Lost the wrong page, I guess. What was really nice about the documentation we had earlier on, actually on their website here, that when we went to it, we could click on these and we can actually get some images of what these plots would look like. Another really nice feature in ggplot, which is very hard to do in base plotting. We showed you could do this par, you could arrange your plots across grids, but to do that in a way that you would have automated, your rows would be your sex, and your columns, rows would be your sex, your columns would be your smoking status. That can get really tricky. ggplot takes care of this for you in these two functions, facet wrap and facet grid. And they're going to create facet subplots of your plots broken out across grids as you have to decide. In a similar way to MFRow, you decide the rows and the columns. So facet grid, I think, is particularly well suited to splitting data by two factors. So when you have like two different males, females, and then another category you want to split down, the columns or the rows. So in order to use this, we just need to specify our standard ggplot. And here I'm doing height, weight. The color is the sex. And I'm going to make a geom point. And then I'm going to add to this facet grid at the end. And I'm going to tell it I want the smoking status. So this is the column. We're going to use smokes. I want that to be the rows. And I want the columns to be the sex. Now I can quickly split up my plot, right? I get my, this is called a strip, this section here, this where the title is. So we have our strips, and in there we have our female, male, non-smoker, smoker. So this is really something you would struggle, I would struggle to build in base graphics, right? But I get it here once I've set up my ggplot with one additional function, and I can tell it smokes by sex. If you just have one factor, or you just want to use one factor for the faceting, you can do that too. So here to facet across columns, we're going to do this about sign columns, so facet grid columns, but we don't put anything in front of this sign. Okay, so here we're going to do facet sign, facet grid, and then by sex, and it's just going to facet across the columns. If I want to go by rows, I can do something really similar. I just need to add additionally after this about sign, I'm going to put in a dot. I don't need that here, but I do need it here. It's just the way formulas work in R. Okay, but here I can do exactly the same setup, and I want to go by rows instead. I just do sex, and then I do my sign, and then I do a dot afterwards, and now I have rows. Facet wrap is a little different. So facet grid is very organized. I'm going to have rows and columns, or rows or columns. So both together, or rows or columns. Facet wrap is really less grid-based structure. And if you have one variable and you just want to split your plot up across that variables, you should use facet wrap. So what it's going to do, in a very similar syntax, we can just do ggplot here, do facet wrap, and we'll do this about sign with smokes. And it's going to try and fill in from left to right. Depending on the size of your window, it's going to work across the categories. What's really nice is that with both facet grid and facet wrap, we can start to make combinations of things to stratify by. So if I don't have a column which captures the information of both your pet and smoking status, I can kind of pseudo create it here by doing facet wrap, and I do this about sign, and I say split it by a combination of pet, smoking status, and gender. And then if you were a smoking female with a bird, then you're going to get your 1 point here. If you were a smoker and a male and a bird had a bird, you're here. So, this isn't a great example. We've had to fit it onto a slide, but you could very quickly produce very complex subplots by using your column information here in combination with this. Again, you can do this in a nicer grid format just to show that it's not just facet wrap. We can have smokes here, and then we can use a combination of sex and pet here to go across the columns. There's an NA, so I guess there's a female without a, oh, there's some type of problem there with the matrix or data frame. Okay, so that's how we can split up our plots, similar to what we were doing with PAR earlier on, an MF row or MF col. We can subset our data into subplots just using this facet grid and facet wrap. So I think the last thing we're going to cover today is this plotting order in ggplot. So we've seen a little bit about, there is an order here, right? Non-smokers going first, smokers were second. If we look here in the sex coloring, females came first, males came second. So we know from when we were looking at factors that they are ordered when you create a factor alpha-numerically. So F became 4M, so female was ordered first in that, in the levels within our factor. So when we do, say here, a G on boxplot, and we do sex by weight, weight's fine, but we have a categorical data along the X. It's going to follow the levels within this sex column. So it's going to look in there, it's going to look at the factor in that sex column, and it's going to say, okay, females with the first level, I will put them on the left. Males with the second level, I'll put them on the right. And if I had a third level, it would be after that, So this is where factors become kind of important. We have an issue here, is that our levels seem to be null, because I think it's actually a character, but I'm going to fix that in R for us now. So in order to change, this order, we need to actually fix the sex column and change the levels within it. So we know we can do that with factors. We can either use the levels function directly on the factor. In this case, I'm going to take that column, I'm going to turn it into a factor again, but this time I'm going to specify the levels in the order I want. Okay, so if I do that now, I'm going to update the sex column, and now when I do my AES map sex to the X and Y to the weight, males came first, females came second. So let's just see that. And it gets a bit confusing because when we started writing this course, factors weren't, strings as factors was different, R updated a bit, but I'm going to show you that now again. So let me get this patience clean. So strings as factors, I'm going to set it to be true. Now, if I look at patience clean, if I look at that sex column, we can see we have a factor, right? And it has levels at the bottom. So what I did on those slides, which didn't actually work, was levels. Okay, so there's, oh, sorry. So I do have levels here now that I've read it in with strings as factors. Okay. So if I did any type of plot, which I think I did one earlier on, maybe color. There you go, sex. So if I do this plot, female is always going to be the first color, male's the second. To update this, we just need to update that column. I need to change levels to be male first, then female. I can do that by recasting the factor like this, and levels, and I will now set the levels explicitly to be the other way around. So now males are red, females. So it's really important to be able to relevel your factors, because it's going to affect all your ggplots. But when we get into things like dseek2, lots of other programs will assume that there's a reason that you have your categories in a particular order. And often it believes your first one, the first level, is your baseline, your control. That's the end of our lectures for today. I have an exercise here, and I put in all the pictures so that we should know what we're going to get or what we want to get. So if you can work through this, we're going to come back at around 5 o'clock, maybe just before 5 o'clock, because we're finishing it a little early. If you have any issues, contact us. Matt will be in the room. I'll be in the room. And we'll go through this, as I say, at just before 5 o'clock. Okay, I'll pause the recording now, and then we can resume. The question was fundamentally, what is the difference between this and this? Correct me if I'm wrong, Carolyn, I haven't got the question right. So what is the difference between this and this? And here we're putting this AES argument inside the ggplot call. Okay, so we're saying mapping AES and putting that inside, and here we're putting it afterwards. For me, these are exactly the same internally. They will produce the exact same plot. I need to make sure my chat's on.
Sorry, I thought, so what I meant was to add the AES function inside of the geom, instead of the geometry function.
I see. So a third way, it is exactly the same.
Yeah.
So all these things will produce geom bar. Oh, that didn't work. I guess it has to do that in there. Mapping. Oh, wait. Oh, sorry. I've changed that to geom thing now. Pick that out. That will all look the same. So they're all going to give you the same results. The reason I show you them actually is just that you may not want, so at this point, I can save this ggplot object like that. I could have that object sitting around in my memory. It can't produce anything yet. But then as I want to do different plots with it, I might find that that's the easiest way for me to do that. And I can specify inside here particular things for the type of geom I want to plot. So if I want to do a bar plot, I don't necessarily want to change the original object, but now I can just change my aesthetic mappings here and do this. Okay, but then I can have the same ggplot object to begin with. Just whatever fits your coding style, really. If I know everything I want to do about the plot right up front, I will run it like that. If I decide that actually I'm going to try and plot this a few different ways, I might decide I just want to build my empty ggplot object, no mappings yet, and then just add the AES inside here.
I was asking, and I'm sure you'll go through it, because in exercise 13, I tried to put the, coloring by sex within the EAS, but I was not able to get the exact result unless I put it within the geometry function. But yeah.
Let's try. Let's have a go. When we get to 13, we can have a go.
Yeah. Thank you.
Okay, so first things first, what do we have to do? Oh, that's my actual code. Okay. So I'm gonna share my whole screen. Okay, so ggplot. So the first thing we had to do, and it's going to take me a while just to get this organized. Read in the data, so that's easy enough. Read in the data, it is a data frame. We have it in the data directory, patients clean ggplot2, it's tab separated. And then we should get our data frame, however many rows, columns there. Ooh. Using the patient data set, why is that? Spelling mistake, 2 words. Generate a scatter plot of BMI versus weight. So I just need to set this up. So I have my ggplot. I need to load the library first because it's not available in base. I'm going to set the data to be my patient's clean. It's going to be a point plot, so it's a geom point. And in the mapping, I'm going to do mapping equals AAS, X equals BMI, Y equals weight. Okay. So it's just a simple XY plot, weight here, BMI here. The important thing is I set the mapping here, and then I set my geom here. Extending the plot from exercise 2, add a color scale to the scatter plot based on the height variable. Okay, so all we have to do at this point is add one more thing to our aesthetic mapping. We need to adjust this to add a color scale. So I got color, I'm mapping that to the height. And then we can just do this. And then it's done, as we can see, and we'll cover this in section 2, how we can control this a bit. It's given us a nice scale, and it's given us a continuous scale here, going from dark blue to light blue. The height onto this as well. Following from the exercise 3, split the BMI versus weight plot into a grid plot separated by smoking status and sex. Okay, so I will take the same plot. I have that now here. Plot. I just need to do it by, by the way, we have smokers along the columns, gender across sex across the rows. So it's rows, then columns, sex, then smokes. Yeah, that's simple enough. Is that the same? Yeah. Using an additional geom, add an extra layer or a fit line to the solution from number 3. So number 3 was here. I'm going to add a fit line. So I think we needed to look something up maybe for that one. Oh no, we can just add a geom smooth. So we saw that earlier on, and we're not doing anything complex at this point. So we just do our same plot we did in number 3. Ooh, did I do that? Number 3. Plot. And then I could just add to that my geom smooth. So here I'm actually writing it out again, but I think I can just do this. Do a smooth line fit. Here I've written out the solution for number 3, and then I've added another geom on top of that, and that is that smooth. Does the fit in question 5 look good? Look at the description for geom smooth, adjust the method for a better fit. So all we needed to do here was question mark geom smooth. I think if we went down, it's got some information on methods. So we could have just cycled through some of these methods. I think LM was the good one here. There are a few other ones which looked better. What was the default? I think it's low S, actually. Okay, and then the next thing we changed is display confidence interval around the smooth. True by default. So we want to remove maybe our confidence interval. I'm going to get rid of this kind of annoying line around the outside. If I fit that, go much better. This is just a linear model, so a linear line through our data. Generate a box plot of BMIs comparing smokers and non-smokers. Okay, so we have our patients' data there, smokers, so that's our categorical data there, and the X, and then Y, the BMI. Easy enough. Following from the box plot comparing smokers and non-smokers in exercise 7, color box plot edges. So edges. I made a point about fill and color earlier on. I guess I want to emphasize it here. So if we want to color the actual box itself, we would use fill. In this case, we're going to use color. I'm going to set the thing to be by sex. Again, if I put that to be fill, it makes a plot more like I think people expect. Okay. Now reproduce the box plots in 8 groups by smoker, colored by sex. but now include a facet for people of different age, using the age code. Okay, so similar setup then, box, smokes, BMI, color, sex, G on box plot, but then I'm going to do facet wrap and separate facets for people of different ages. Okay. So again, it was I think it was the plot from here. And it just shows the nice way you can kind of build on top of ggplots. It's not this pen and paper model. It's holding the whole thing in memory so that we can just adjust later on. Cool. Use a similar box plot of BMIs, but this time group data by sex, color by age, and facet by smoking status. So I think here was just deliberately, I think this is a common problem which people come across. So let's run it with a problem. So same as above, we would have patient's data. We're going to do map X will be the sex now. Before is whether you smoke. Y will still be BMI. But now we're going to color the edges by the age. If I get rid of that, what happens? Okay. If we do it like this, though, okay. So the issue here is that we want to use color. We want to produce categories from our age, right? And if we look at our patient's clean data frame, we can see that age is in numeric. Okay, so it's not a factor in any way. Class, integer. So in order to get categories from it, though, we need it to be a factor, which is, I think, often something which people will get stuck on. So in this case, we're actually modifying it inside the plot. So we're saying color is the factor of age. We could update the original data frame and change that particular column to be a factor. That's dangerous, though, because sometimes I might want to plot the age as a numeric, so I don't want to alter my original data. So just assuming we got that to work, generate or regenerate solution to exercise 10, but this time using a violin plot. Okay, so all we need to do then is change G on box plot to G on violin. We should be able to get the plot. Perfect. Generate a histogram of BMIs with each bar color blue. So we can do the histogram first. So we have patient stay clean here. We're going to use the BMI. Actually, I'm not specifying. I think I should say X equals BMI. If I do that, maybe if I do that without the color first, standard histogram. And then I can just add the color here. I'm not mapping it to a particular aesthetic. I'm changing the whole thing to be blue. Okay. Great. So now we came to the question. I think we had a question. So generate density plots colored by sex here. Okay, actually, it's not true. Colored by, I think I said fill. It's a fill we're doing, so we're going to do fill. So then, generate density plots. So all we need is the same data, geom there, geom AES X equals BMI. And I think if we run that, we should be able to get our plot. Okay. I think the question then became, you know, why do I need that there? And then if we do this. So was that the question, Carolyn?
Yes, for some reason I was not able to get it like that.
Yeah, so but it's similar to what we were talking about earlier on, I guess, as well, is that you can move between where you put these things as long as you're wrapping it here in the AES.
Okay. Thank you. Yeah, I don't know. So I would just get one of the peaks. I don't know why. And
you can look at the end if you're still around. I can always.
Yeah. Okay.
So I think this is a nice example, though, of why I did it as well. So in this case, by having this object, I could have got rid of that, saved the object as plot, and that would have saved me some hassle here, as I could have just done plot. And then later on, I could have ignored, I didn't need to rerun this part. So just comment that out. I want to change into a different geom density, and then I want to start adding aesthetics. I don't need to mess with the original object at this point. So I should just be able to change just this part and maintain the same plot I produced. But it's all about how people like to set it up. So generate a separate density plot of BMI colored by sex for each grade. It's the same plot again. This is really what the exercise is about. It's the fact that you can just use the same code and just modify little bits of it to be able to produce. Oh, I got an NA there as well. To be able to produce lots of different complexities. So that's the end of our session today. I'm going to stop the recording. If you have any questions,